Adam, welcome. Adam Timlett, founder and director of Turing Meta.
Hi there. Thanks, Helgi, for the introduction. Yeah, so essentially what I do, I have a consultancy called Turing Meta, which I set up this year to translate research that I've been doing into leveraging biology in terms of insights from biology and how organizational problems are solved in biology, and how we can leverage that information from that science discipline into understanding better how to actually manage human organizations and human organizational problems. So the idea for using biology as a starting point, rather than directly, looking at organizations, perhaps, which would be the more traditional method, can be understood in these terms. So there is a physicist called John Wheeler who talked about the great smoky dragon of quantum mechanics, and he thought of quantum mechanics as a system that is something that's big yet also hard to see. And so obviously quantum mechanics has its own problems, but this problem of something that is actually so big that is hard to measure is a problem for organizations as well. I can explain, and here is my explanation of this. And this graph is showing on the x-axis the distance between different subjects, and on the y-axis the quality of information and theory in those subjects. And the bar, the dotted line, is the bar for being able to do controlled experiments in that subject. So organizations are big, human organizations are big, yet they are hard to see because scientifically they're hard to measure. If we look at management science, the ability to study organizations directly is impaired by the fact that you can't do controlled experiments on organizations. And so management science, which tries to study organizations directly, falls well below the bar for controlled experiments. It's the same for organizational economics, and it's the same for economics generally in terms of a subject. These are not subjects where controlled experiments are the norm, right? And so that limits the quality of information that you can get. The reason we have controlled experiments in other sciences is precisely to avoid fooling ourselves that we've seen something that we haven't really seen. So, for example, in medical trials, people conduct controlled experiments where they randomly assign the treatment to one person in the group and not another person, and they control for different kinds of factors so that there's a randomized controlled trial. In addition to that, the patients or the people in the subjects in the trial don't know whether they're getting the actual treatment or not. And even the people administering the treatment don't know whether they're giving the real treatment or not, because you can have a placebo pill. So even the person administering that pill, the trial is designed so they don't know whether they've got actually a real pill that they're giving somebody or whether it's just a sugar-coated pill. And so this turns out to be essential to get reliable information, because it's so hard to not fool yourself that you think you've seen something you haven't seen. And we only do this because we do get fooled when we don't do this. So it's not unnecessary. So it's essential for science, to be able to control things this way, but it's not available when you study organizations directly. So obviously the highest quality information theory is in the simplest things that you can study. And physics started off, a few hundred years ago on that route of empirical research. Relatively simple things were being studied, like light through prisms, or heat, or obviously gravity, and so on. And then, the more complex the thing you're studying, the harder it is to actually control the phenomenon. So once you get to chemistry, it's more difficult to control reactions. And then you get to biology. But you notice that we're getting closer to economics. The distance between these subjects is moving towards the more complex phenomena like human organizations. So biological systems deal with the same, because of their complexity, they deal with the same problems that human organizations deal with. They deal with the ability to grow sustainably, how to solve that, viability as how to remain viable. They deal with uncertainty in their environment and how to control that uncertainty, how to deal with it. They deal with how to innovate, and they deal with how to deal with risk and how to be robust. And so all of these things are properties of biological organisms, and have evolved over millions of years, billions of years on this planet. And with controlled experiments, we can start to understand how they really work and how they achieve this. And so what I suggest with my consultancy is that we translate that research from biology to the subjects we're interested in. And this is a scientific thing to do. When we can't study something directly, we create an analog of it, a model of it, and we develop a method to study something indirectly. And this can be more scientific than trying to study it directly, as I've just explained. So you study something you know that you can measure and you can control, and then you understand how it relates to the thing you're interested in. And that's what I've been doing with my research, is figuring out how to translate this research in biology. So how do we achieve this translation? So at this scientific meeting, which was organized by the Royal Society in the UK, but it was actually an international scientific meeting, biologists, physicists, computer scientists all got together to study this concept of computation by natural systems. So it's a way of thinking of a natural system as performing computation, which is a way of thinking of it as doing complex work and using computer theory and models of computation to better understand those systems. So this leads me to realize that scientists are claiming that the way to understand natural systems and translate it is to look at models of computation, because this is universal, right? So once you have a model of computation that you know works, you can apply that readily to human organizations in the same way you applied it to a natural system or to analyze that system. And so this gives us that ability to translate information and empirical research. Okay. So now we've explained why I'm doing what I'm doing and the rationale for it, the methodology. So now you get to the actual content of, like, what is the theory? So the question we can ask straight away, for example, is what is natural selection, or more generally evolution computing? So in this Twitter thread, this person who's some kind of machine learning guy, I think, he argued that Darwinian evolution, which he describes in this way, is a simple method of optimization. And he says it's not very efficient. So Darwinian evolution is optimization. This is what computer scientists normally think of what natural selection does when it computes. They think of it as an optimizing system. So natural selection is just kind of a way of achieving more efficiency or precision about getting closer to a better kind of version of that thing. So an AI researcher, a different one, who I actually happen to follow and respect very much, he replied in this Twitter thread that actually evolution is not one thing. It's a set of entangled search processes. And so there are different kinds of search from the perspective of computation that he describes here. I won't go into them, but there's quality, diversity, novelty search, competition, escape, all these different things that also happen at the same time. So what this tells us, right, what this reduces to is that there are these competing computations for innovation, for robustness, right? On top of that basic computation for more efficiency, for more reproductive rate, for a higher reproductive rate. And so this is similar to what human organizations are doing. We can think of natural computation as a chimera. So a chimera is a mythical creature. This is a chimera. It's come from Greek mythology. It's got the head of a lion, the body of a goat, and the tail of a snake. And so it's actually a word we use to describe something that's completely impossible, doesn't exist. But I want to use it here to explain that the work that's being done by a biological system, we now know, is like this. If it's doing more of one thing, it's doing less of something else. It's not really one organization or one structure. It's overlaid different structures doing different things. Right, so here is a concrete example of what I mean by this kind of overlapping computations. There is a process called apoptosis, which is the process by which the cells in your body will automatically there'll be a signal released by the neighboring cells, and those cells that receive that signal should basically decide that they will self-destruct, so in a controlled way, so that basically it can be used as a way of controlling the cells in your body. And for example, cells that may be at risk of becoming cancerous, they can be the neighboring cells can detect that somehow and release this signal, this molecular signal that tells those cells to self-destruct. And so this is a way of protecting your body, because obviously cells are growing and dying all the time in your body and replenishing themselves. But this process is part of that process by which, for different reasons, your cells are transmitting information to each other, and sometimes they're telling them to perform apoptosis, which is a way of controlling that process. But what this researcher, Eric Deeds from the University of Kansas, what he found was that when that signal is transmitted to the cells, it's not reliable. So he highlights here what he's calling the channel capacity as 0.92 bits. So this is a computation. We're measuring nature as if it's doing a computation here, and we're saying this computation seems to be unreliable. But what it means, because it's less than 1 bit, it's not a reliable signal. So the cells that he measured do not reliably respond to this signal. And that seems weird, because if it should self-destruct, if that's the signal, why isn't this reliably happening? So the theory is that there's another computation which is overlaid on top of this one that's also going on. And so what Eric believes is that if there's some noise that's causing that signal to be released, right? If there's some unreliability to the signal itself, if that signal was responded to completely faithfully all the time, you would end up potentially with voids in your body of lots and lots of cells being destroyed, right, in this way, wrongly. And so by having a slightly unreliable signal, it smooths that process of the cells in your body being destroyed, so that they do not all get destroyed in a small concentration. And so this allows the system to be more regulated. But what it does mean is that there's probably another signal somewhere that is overriding that in some sense and giving more information to say, in this particular case, you really should self-destruct. And so there's probably other signals going on. And so what does this mean? So this is biology. This is what's going on in terms of, cutting edge biology. How do we interpret this in terms of what it means for organizations? What is this empirical data that we can trust telling us about how to organize? So what it tells us is that when we look at organized cell death, for example, there's different priorities. There's the priority of a well-organized cell death in precancerous cells, of causing that. And there's also this risk of causing voids in your body due to imprecision of that signal itself. And so there has to be extra information to decide when you should do this or do the other thing. No one computation can do both. They overlap, and there has to be extra information to decide in any given case what I should be doing. Evolution itself overall involves efficiency and fitness as a kind of like survival of the fittest idea. But at the same time, we now know that it's also computing not just the fitness of an organism, but also the overall robustness of populations, innovation within a population, how to cooperate under uncertainty. All of these overlapping computations in some areas, in some places, in some parts of the genome are being favored over and above the fitness computation. So again, we have this chimerical idea, and the solution to this chimera, the reason why it's not just a mess, is extra information to tell us how to organize in a specific case versus another case, or what to compute, if you like. And so this is the concept of playing organization games. So this is the concept that I've developed from this research, that we basically, instead of having a messy compromise where we randomly choose one thing or the other, we have to expect that there's extra information that's allowing nature to choose one form or another form at the right time. And so this is what we should learn from nature as a fundamental principle of organizational design, that we should be looking for ways to easily switch from one organization to another as required. And so an example of, like, if you're in an organization and the kind of challenges you face is the parable of the blind men and the elephant. And so this is an ancient parable from India. And there's this idea that one person grabs the tail of the elephant and says that an elephant that they don't know what an elephant is, but by grabbing the tail, they think it must be a snake. Another feels the leg and says an elephant is actually a pillar. A third feels the body and says, no, an elephant is clearly a wall. And so obviously this is a story about not being able to see the big picture, as I said, not being able to see the dragon. But what it does is it means people in different parts of the organization focus on one aspect of the computation that the organization has to do. And we need to sort of think about how to actually achieve the right organization in the right context to see the whole thing. An uninformed compromise is not of good value, but if we use information to make those decisions, then you can achieve a much higher value result. And then you get this chimerical idea emerging from this. So we need this intermediary signal almost to intermediate between different actors in an organization and to enable them to resolve in the best way for the organization. And so that gives you a higher payoff. And the mathematics of this is called an organization game, and it relates to the mathematics of game theory. And so the advantage of developing this maths in this way is that you can study a biological system with the same maths that you can study a human organization, because you've identified the common factor. So what are organization games? So if organizations are chimerical in this sense, the best organization is neither one form or another, but both forms, for example, right? So neither a hierarchy nor a flat structure, but both are in fact the best thing for your organization. And we should create an organization that can adjust the structure to fit different tasks as it needs to. Now, you can only do that to some extent, right? So we'll talk about that. But we can use game theory to study how easy it is to adjust the organization we currently have to a different structure. And so game theory helps us in different ways to do this. So this is a paper, this is some slides that I've borrowed off the internet from a guy named David Bartolini. He was presenting to the OECD, which is the Organization for Economic Cooperation and Development, and he was explaining how to use game theory to help them to cooperate better. So different NGOs and governments, charities, different actors in different countries being able to cooperate and using game theory to understand it. So this is about classical game theory, and we can use this in organizations to understand how easy it is to form temporary larger structures. And so as the structures we want to form follow the contours of the actual organization as it currently is less and less, they get harder to form, right? So I'll kind of explain this here. So let's just take a typical, org chart where you have some kind of org chart like this. This is the default organization, let's say, of this particular organization, the default structure. If you want to act unilaterally, which means on your own, right, you can do that within your unit. So each of these circles corresponds to a functional unit. Only the people in that unit, could be one person, could be a couple of people, only they need to agree to achieve that action, right? That's due to the way the organization is set up, because you've decided these people are in this one unit, this one person has this role. If you want to achieve bilateral action, which is two teams to work together, right? Then that might be because, you know, in terms of meetings that are cross-functional, small projects, more strategic decisions, you go outside of the default structure, if you like, which is the unilateral function, the capabilities that are unilateral. And so you get these bilateral, so you get more than one function working together. Now, even if one function is underneath another one, I'm still going to call it bilateral because it's clearly slightly more work to organize than when it's within that same level, or for example. Now, if you want to form a bilateral organization that is not within the structure, like this one, it's less natural because the organization you formed means that you're crossing, they're further apart, there's less natural alignment there. And so game theory tells us what strategies we should adopt and when we're stepping outside of the natural organizational structure. But the whole gist of this is that we shouldn't expect one organizational structure to be the best, right? We're looking at the temporary structures that you would have to form, right? And so there would be information would flow into the organization that we now need to form this temporary structure within the organization. And this is allowing us to see how that works and what strategies we would use to achieve that. And this is classical game theory. If you want to reorganize the structure, it changes the natural alignments. The simplest effect of a reorganization is that what was bilateral now becomes unilateral, right? So the typical way that people try to reorganize is they say, this particular function is actually not just a temporary thing. We need to do this all the time. This is a growing part of the business, but it's spread across two functions. So we're going to reorganize and make this one function. And so now that thing that you're interested in can be a specific team just for that particular thing. And that can be part of the new structure of the organization. So now you've achieved making that thing that was bilateral or multilateral, a unilateral function. And that's the way people intuitively think about reorganizations a lot of the time, at least in terms of the business, I think. So when you look at game theory, again, David Bartolini's slides are here. I've annotated these slides. You get different kinds of failures of coordination based on the level of alignment. And so different games are about different levels of pre-existing alignment between the people playing those games in terms of trying to cooperate. And the game theories just use this language of games. It's obviously they're not really games here, but it's just it's the term that they use. But in decreasing order of alignment, you have the pure coordination game, then Battle of the Sexes, and the Prisoner's Dilemma. And so each problem of moving to a larger temporary organization gets bigger the less natural alignment there is in the current organization relative to the temporary organization you're trying to form. So the way it works is that if you have a pure coordination game, this is the simplest kind of game to sort of solve, if you like, in terms of achieving cooperation. So if you had two different functional organizations, we'll call them player one and player two. So it's two different people within the organization. Then the player one's choices can be written as A and B. So they have a choice in terms of what they're doing. So this is the action that they're trying to achieve. And player two also has two choices, A and B. And so we can think of this as, for example, if we're trying to agree what activity we want to do, each person has two choices, but we not necessarily going to agree on those choices. And so depending on the combination of actions that we choose, we get different payoffs. And normally what you do is you write the payoffs in this matrix. So the payoffs to player one can be written in red. And you can see that if they both agree to do option A, player one gets a reward of 2. But if one chooses A and the other chooses B, whichever way round it is, player one gets nothing. And if they both agree to do option B, player one gets a payoff of 1. And the payoff is just like the reward. An example would be if you're playing, we want to play a game together. We want to play football. We're trying to organize that. Or we don't know what game it is we want to play, but we know we're going to play a game. And player two payoffs in this example of a pure coordination game are the same as player one.
So it looks rational to get the highest payoff that we should agree to play the same sport, for example. So let's say that there's Adam and Joe, and Adam is player 1, Joe is player 2, and Adam and Joe want to play some sport, and we both prefer to play football. So Adam brings the football, and Joe's going to bring the goalpost, and then we're going to play football. But if it should be fine, we should end up playing football if that's what we both prefer, because we both prefer the same thing. But it can happen without information flowing properly that we choose the less optimal thing, which is to play cricket instead, because I might think wrongly that Joe prefers to play cricket and I'll bring a cricket bat, and Joe thinks wrongly that I prefer to play cricket and he brings cricket balls. And so we both end up playing cricket, even though we both wanted to play football. So this kind of confusion is what this game is modeling, but it's a minor problem because we're both naturally aligned. We both want the same thing. And so the solution to this kind of problem is what's called just sharing information. So if we both know what it is we actually want, we'll choose the best choice for both of us. And obviously, if we get completely confused, and I think we're playing football and Joe thinks we're playing cricket, then I bring the football, Joe brings the cricket balls, and we don't play anything and we get nothing. So this is this idea of a pure coordination game. And so this is kind of the way you solve this in an organization is that you have the right information flows, so that this is all about communication, right? And so your healthy default organization should have information flows for the people who are aligned so that they can smoothly get to the best decision all the time. That's what your organization is trying to achieve. So when you're designing an organization, you want to make sure that the people who are constantly working together to achieve something obviously are close together so that they can do that and that they're communicating well. This kind of corresponds to this thing on the org chart where you have two people, comms and the marketing, and they're closely aligned already within the organization. So the information should flow more naturally and you should resolve this problem. Okay, so if you had the next one down, which is slightly more difficult, this is called the battle of the sexes in game theory. And here you can see that we're not quite aligned. So player 1, gets a high payoff if they both choose option A, but player 2 only gets a payoff of 1 if they both choose option A. And it's reversed if they both choose option B. So this example is where, for example, Adam and Joe both want to meet, but Adam prefers to meet I prefer to meet at my house if we both meet there, and Joe prefers if we both meet at his house. And so we want to meet and we get nothing if we don't meet, right? But we don't always we both have different preferences about where to meet. And the natural solution to this is involves some bargaining or some negotiation. So if you have a problem like this, right, where naturally there's going to be some difference of opinion, you want that ability to negotiate and bargain in order to solve the problem. Now, the risk with that is with a slightly different set of payoffs, you can show that you can sometimes get a messy compromise, right, where you don't get the best payoff for the whole organization. So this is one of the problems that can happen when teams are not well aligned but are working together, is that there has to be compromises and negotiation, and maybe that's not the best thing for the organization. So the example of this could be this example we talked about earlier, where you have two teams that are not as naturally aligned, right? Or it could be this example where, in fact, even within closer part of the organization, they're not naturally aligned. But the idea that you can smoothly negotiate or you can reduce the need for negotiation is part of the way you design the organization so that people are more naturally aligned, to avoid this kind of negotiation slowing down decisions and so on. Now, the most difficult problem, if you like, in game theory is called the prisoner's dilemma. So in here, the alignment is really bad. And instead of options A and B, we've got C and NC. And this stands for cooperation and non-cooperation. And what it's supposed to represent is the situation where we both agree on something, Adam and Joe agree on something, but Joe knows that if he actually doesn't do what Adam and Joe agreed, that Joe gets a bigger payoff as long as Adam does his bit thinking that we're doing this and Joe does nothing. And so you actually get a reward for kind of cheating. And so that's what this kind of represents. And, you know, examples in an organization is where people agree to do things, but because they're not really aligned, it's easier to just pretend to agree than actually do them, right? And then maybe one team does more of the work and the other team is what's called a free rider. In other words, they just get the benefits of the work without doing any of the actual investing in it in terms of the cost to them. And so this is a central kind of thing in game theory because of this lack of alignment. And the solution is seen as contracts. So the solution is seen as essentially changing the incentives. So there's a real penalty for not cooperating and cheating. And so this is very intuitive to people in the sense that they think that you have to use authority within an organization. You have to throw your weight around sometimes. You have to say, look, if you don't do this, you're in trouble. You know, there has to be some kind of soft power or whatever it is to try and, you know, I have to go to someone more senior to make sure that this happens and all this kind of stuff. So the solution is, as I say, to change the incentives so that you don't get a big payoff for actually cheating and not doing the work. You reduce that, say, to 1, and then it's more rational to cooperate. But the problem with this whole approach of like throwing your weight around, creating real penalties, the risk of things happening, is that it's expensive. How do you enforce it? It's costly. So you don't want to get into an organization where this is the solution to all your problems all the time, is to kind of threaten people and escalate things and so on. Obviously, this is bad for an organization. It's more likely to happen when people are temporarily trying to achieve cooperation between teams that are not naturally aligned. It makes sense, right? So let's go back to the pure coordination game. So this is the one where we're perfectly aligned, but maybe we don't have perfect information. That would be the risk. You can represent this example by simplifying it because the payoff to each person is the same. And we can basically write that as 4 and 2 instead of 2, 2 and 1, 1. And so this is seen as very, very simple and is not studied very much, right? As a relatively compared to these other things. So what I've been talking about is classical game theory, but I think it's really important from looking at biology to understand this side of game theory that I'm going to explain, that I've been working on. And I've been working on this in relation to biology because this, what I'm going to explain, makes more sense in biology, especially to organisms and so on. So in classical game theory, this is a minor problem and there's not much a big deal. It's just about information. But you'll notice that I was talking about information a lot earlier. So what I call an organization game is where there's actually different solutions and strategies as because what's happening is that the payoffs are moving from one game to another as the best solution. So an example of this is if we're having a conversation and it might be for a while the best thing if Adam and Joe are having a conversation, it might be the best thing if Adam does almost all the talking. That's what we get the most out of the conversation, from Adam doing most of the talking. But over a short period of time, it might be that the value changes so that now it's better if Joe does more of the talking. And this is just a natural conversational thing that happens, right? It makes sense. We detect the change in value of information. We interrupt people, or if we realize we're running out of things to say, we stop talking. And so the strategy now is whether you're talking or not talking. And that's what you're changing. If we both do talk, then it's 50-50. If neither of us talk, the conversation is over. And so we're interested in this as a game, right? But it's a different kind of game to what we were talking about before. It's all about the payoffs changing and us adapting as the payoffs change. So if in this example, I've got Alice and Bob, they're both talking to each other. Let's say that's the best payoff for a while, right? And then over time, It changes. This is analogous to an organization, which is also about information flows. So when we design an organization, it has a certain balance to it. And we look at the people who have their roles in that organization. Every person has different strengths and weaknesses within the organization. So we have the chart, right? But within the chart are actual people, and each person has different strengths and weaknesses. Now, when you create a formal structure of an organization, it's like a conversation that has a default flow. So by default, this person does more talking than this person because of the nature, like for example, the rules of a debate or something. And this is what the org structure is kind of representing in some sense. But sometimes as the value changes in a given context, you want to change that flow of information. And so the new best payoff changes to, for example, Alice not talking and Bob doing all the talking. So what does this mean for an organization? It means that we would try to consider how the default structure creates certain information flows by default, and how you would want to actually amplify the strengths of people within the organization that are part of that organization, and minimize their weaknesses. And you would change the flow of the organization, the flow of information, to recognize those strengths and weaknesses as they affect different subjects within the organization. So the best payoff is changing for everybody. We're talking about the joint payoff. And so it's a game of pure coordination, but in fact, the value of the game itself is changing, and we're trying to adapt. So in a matrix form, it looks like this. So these are kind of different games with different payoffs, and these arrows represent the value going from one game as the game that we're playing to another game. And so the best strategy for one person or another is now changing. And so this is mathematically what it looks like. And some games are easier to adapt to as they change than others. And so the red arrow indicates where two people would have to change their strategy to keep the conversation with the highest payoff. So compromise in terms of randomly choosing your strategy doesn't work. If you just randomly choose two strategies, the payoff depends on what game you're actually playing, right? So you need to know what game you're actually playing, which is the subject of that particular thing. So what are the strengths and weaknesses of the people in that particular context? Adapt to that. And so compromise, where it's just randomly done, doesn't pay off. But sensitivity to the value, the strengths and weaknesses of the people within the organization, this pays off, right? And so what we're interested in is how far does the organization by default map to, one of these games. It'll map to one of them by default, but in a given context, the game might be different. And so the strengths and weaknesses of the people within the organization will determine what game you're actually playing at that time. So if we go back to the organizational structure, now we can think of it in terms of information flows. So the major decisions are coming down from the top. They're cascading from strategy, from top level management. And there are also significant information flows between related teams. And there are minor decisions and corrections coming from below. And there's typically very little information between certain teams who are not related in the organization. Now, the actual game you're playing depends on the specific strengths and weaknesses of the people in those roles in a given context. So in biology, there is this thing called hitchhiking and background selection. So this is where good genes hitchhike on the success bad genes hitchhike on the success of good genes that they're very close to in the genome. So when natural selection happens, the good genes get selected by natural selection, and the bad genes also get selected if they're very close to the good genes. And so you get this problem of what's called genetic hitchhiking, and this is analogous to what we see in management as well, because person in a management position has good ideas, right? But they also have some bad ideas. And by default, because of their role in the organization, the bad ideas are hitchhiking on the fact that that person who has those bad ideas also has good ideas. And so their good ideas are obviously fine, but it's when we don't react to the bad ideas. That's when we're losing that ability to switch the flow of information, which we want to do. So, you know, the people at more strategic levels are more likely to have hitchhiking information, if you like. So they're responsible for stronger decisions, but also weaker decisions. The organization naturally amplifies all their information. Conversely, people lower down in the organization, they are not as have their ideas as amplified, if you like, within the organization, because the organizational structure doesn't allow it so easily. And so they suffer from what the equivalent of background selection. And this is where good genes that are next to bad genes get selected out of the population because the bad genes are overpower, you know, having being selected against, and the good genes are too close to them. So even though those good genes are good, they're too close to bad genes to actually be retained in the population. And so this is the analogy with biology. So organization games should allow you to change and recognize what game you're playing in terms of the good or the bad information. And as we move from different tasks, we should look at the strengths and weaknesses of the people within the organization and actually adjust how we work within that organization. So if you're a project manager, for example, this is a very typical role. You're naturally a bit of a hitchhiker, right? So you naturally have strengths of organization, coordination, and planning. But by default, your role within a project it allows you to amplify your opinions, often quite subtly, on strategic decisions too. So any weaknesses in this area in terms of the project manager hitchhikes on their strengths, right? Because of the organization, because of the default position they have in the organization. So you want to kind of minimize those weaknesses. For a technical independent contributor, they are often closer to the details of decision making, but they often have a lot of strategic knowledge. They have a lot of subject matter expert knowledge, but it's easy for that to get filtered out. So you want to amplify those decisions to compensate for the default structure of the organization on a case-by-case basis. Okay, so here's another example. Let's say that you have the manager of an organization and they send out an email, and the email is sent to everybody in the organization, and they do this regularly, and only some people bother reading the email. So you have two choices there, right? For some people, the information is not relevant, right? So they don't read it. So it's within they can unilaterally ignore the email because they don't have time to read it. Let's say it's a very long email. It doesn't seem to be relevant, right? Now, the CEO could decide that the information is relevant. Everybody has to read it, and could start, you know, being alerted as to people not reading it, and then kind of like throw his weight around and say, I send these emails out for a reason. I need you to read them, and so on. Tell all the managers that all of their staff should be reading these emails. So this would be a classical game theory where you basically say, okay, maybe our interests are not aligned, so I'm going to throw my weight around, and I'm going to adjust this by forcing you to read the email. There's a classical enforcement solution, right? And so this is what you see intuitively. People relate to this sort of idea quite naturally. But actually what's happening is that the quality of the task is being computed by the organization. And so some people find the email relevant, other people do not. And so they're flexibly responding sensitively to the quality of the task. What's the value of reading this email, right? So the way an organization game view on this would be is that we're naturally just adjusting to the value of this information, right? So it's not a case of throwing your weight around. It's a case of actually recognizing that we're playing an organization game and we're being sensitive about the use of our time. But the default organization tends to waste people's time. So Elon Musk, when he took over X, Twitter, whatever, I'm not a fan of his, but I did notice that he told people to leave meetings if they were asked to attend a meeting but didn't really have anything to say in the meeting. He said, you should leave the meeting and you should tell them you're leaving because I said so, and ignore if it's your manager, I don't care, just leave the meeting, right? If it's not relevant to you, they're wasting your time. And so this is an example, ironically, of him throwing his weight around, right, as the new CEO of X or whatever. But it's a reasonable kind of point, right? So the question is, what game do you think you're playing? What are you doing with the value of your information, right? It's not just about aligning incentives with classical game theory. It's not just about sort of changing the incentives for people to work together. It's also about being sensitive to the value of the information in front of you and having that freedom to unilaterally change the flow of the information. And you should design organizations that allow you to do this and recognize that there is no best structure and that these dynamic changes are essential, as we see in nature, to resolve these problems, because these problems are chimerical, right? There is no best structure. So this is the main result from biology, and it also echoes Conway's law, this correlation between structure and information. There's this basic kind of relationship there that we need to pay attention to when we're designing organizations. So we can't just look at the organization as a structure. We have to think of it as flows of information, and we have to think of it as dynamic. We have to think of the behavior, how we design the behavior to compensate for the weaknesses of any default structure we choose. So going back to these organization games, we need to identify the inbuilt biases in any structure that we choose. There's the default, and then there's the temporary structures we're going to have to form within it. We need to compensate for the various ways in which the structure has a weakness and the people within it have weaknesses. And we should use classical game theory and organization games to help us to form temporary structures. And we should identify, obviously the strengths and weaknesses of people as part of the design of the organization, which obviously changes as people change. And we should basically be playing these games and understand this concept of hitchhiking and background selection. It's an incredibly useful thing from biology to understand. It's a real empirical thing. We're going to be a far more effective organization, whatever structure we choose, right? If we're able to dynamically respond to the value of the structure that we need to temporarily form or break up. So just to summarize classical game theory and organization games. So classical game theory, teams are cooperative or non-cooperative depending on their incentives. And we can try to force changes to the game by changing the incentives. It has a lot in common with psychology, reinforcement learning. It also relates to contracts. People understand contracts this way. It's ways to manage suppliers, conditional bonuses. And there's this concept of free riders, people who pretend to work, but they're not really working. It's good for understanding the challenges of forming less natural structures within your organization. And hitchhiking here refers to people who are basically not doing the work, but benefiting. You also have organization games. So teams detect natural changes in the payoffs of games, and then they react. It has more in common with physics. There's a thing called Maxwell's demon I won't go into, but it has something in common with that. And it has more in common with biological systems. It leverages the ability to adopt temporary structures in response to the change in the value of that structure. And hitchhiking here refers to information, low quality information, which is benefiting because it's so close to high quality information within the role that person has in a department. So organizations misdiagnose their issues if they only look at classical game theory and do not learn from biology and also look at organization games. So instead of looking at it from only one point of view, we want to look with both of these points of view at the same time. So the organizational manifesto is the org squared or org 2 organic organization. Is this idea that organizations are chimerical. There is no fundamentally correct organization for a particular business. There's no single organizational form that we should adopt. We should predict and model temporary. Even when we design the default structure, we should try and predict the temporary structures that will have to be formed within it. We should co-design in terms of the behaviors that are complementary to that default structure, which will compensate for the weakness within that structure, which has to be there because they all have weaknesses. And we want to raise efficiency and reduce costs by making informed
compromises, not uninformed compromises. And so we want to train organizations, people within that, to play these kind of games, just like Elon Musk was trying to do with X. And we want to make the culture about the value of information and adaptation. So as part of this, in terms of our attitude, we have to figure out that there's more than one way to do something over the one best way to do something. And we have to look critically at information flows and how we understand the value of the structures that we're forming. And biology is telling us that this is what makes reliable complexity and cooperation possible. And so it's very deep, is what I'm saying, is this is a very deep principle. And we know it's deep because we've used empirical biological research to help us to understand it. And there are hundreds and hundreds of studies that have been collectively analyzed and reviewed in papers that I've reviewed that I haven't talked about at all, but there's a lot of incredibly valuable research that's telling us that this is important. In terms of takeaways, ask yourself what organization problems you see and how you think they should best be solved. Do they require a reorganization? i.e., what was a bilateral coordination problem should be unilateral? Do you require better incentives for teams, better objective setting, better information sharing, or better even forms of negotiation between teams? Do you think about organization games now? So the ability to adapt the organization based on the information that's of value about that particular organization, and think about compensating for weaknesses in the default roles of people in that organization. So that's the end of the talk. I don't know how long it's been. These are some of the books if you're interested in further reading, but I'd like to open it up for discussion.
Thank you so much, Adam. We don't have that many minutes, but we definitely have a couple of minutes for some questions. One question came into the chat from Dinosa. Let's see. What would be some techniques to understand what kind of games are being played between teams? What are the techniques to identify that?
Yeah, so I think that it depends. Obviously, a lot of the information that we're talking about in terms of the communication between teams is not structured information. It's informal information. It's information that is just from conversations or some emails and stuff. So you can't analyze it in the way that you'd analyze more formal kind of information flows, like the flow of data between companies and stuff. But there's still principles that you can use where basically part of it is psychology. You have to ask yourself, what are the incentives of these teams? Are they aligned? That's what people are normally talking about. They're saying, the objectives of those teams. So for example, do they share objectives? No, within the organization, if you set KPIs, do they have the same KPIs? Do they have actually quite different KPIs within that organization? This is telling you the level of alignment that is likely to lead to differences.
One last question just for me. Can you give us an example of how this can be applied in like a real life situation? Have you implemented somewhere that you can give us a little bit insight into how that was and on what it was implemented? Implemented.
Yeah. So I mean, I started this consultancy this year. The research that's gone into it has been over a number of years, right? So the whole idea of this research is that we get information from biological systems, which is more reliable source of information. But in terms of the take-up of people who are now using this ideas, when I talk to companies, I see a lot of natural fit with what people are already doing in different scenarios. So what I would say is that when you go away and you engage with people and you workshop and you talk about these ideas, I get positive feedback that I recognize this situation, and I see this because it's something that's naturally the way that wasn't so formally described right before, but it's something that's intuitive in some sense, right? And so in terms of the next steps, like how would you use this information, right? It's up to you how you would use it. So the way that you would implement it, right, is that you wouldn't say, this is what you should do. You would say, here is some something to help you get a better understanding of the problems that you're familiar with in your business, right? How do you think that would, what ideas does that give you about how to organize, right? So you can do it in a very organic way. But if you were setting out to reorganize a company from the start, right? No, I haven't done that, right? But I don't think that would be the way to necessarily do this anyway.
Okay. Thank you so much. Is there any last questions? Maybe I have time for one more question if any of you has one. Nope. Then basically, thank you so much, Adam. Thank you for the introduction and the presentation. It was really interesting and fun to see. So thank you guys, and have a good time.
All right. Thank you.
Bye-bye.
Bye.